Welcome back, nerds. So, it's so bizarre. Before lunch, people like chuckled. Like, I'm not really trying to make you laugh, but people at least reacted. Fifth and sixth hour, nobody cared at all that I entered with a very aggressive start calling you all nerds, which is interesting.
Nerd is a good thing. It means I'm smart.
I don't think nerd is a bad thing. It depends on how you're using it. If I say it aggressively like that, I'd probably assume you were trying to talk some smack.
What's up, nerd?
Yeah, nerd. All right, anyway. Okay, today, super chill, super easy, I hope, I think, and I think you'll think. But here we go. We are looking at 3.2. Now, we have seen this word before, but we are not doing sequences. This word is what? So it depends, because you don't know yet if it's an adjective or a noun, right? So if it's a noun, I would say arithmetic. If it's the act of doing this, it's arithmetic. And I'm going to say it's arithmetic right now. We're going to say arithmetic and polynomials. Okay. For this, I'm going to, without saying anything, I just want to see what your gut tells you to do. And we're going to do a small example. And my guess, even if I just say, what does your gut say? I could change the language and say, how would you want this to work? And I bet we all do the same thing still, because naturally we do this. So before anything else, just a quick reminder, what is arithmetic? It is the simplest things in math. Addition is one of them. Subtraction. Multiplication and division. This is arithmetic. That's all it means. If you look back at chapter 1, I don't have my wireless one. In chapter 1, we did arithmetic sequences because they kept adding the same thing. That's what makes it arithmetic. Now, as we go through here, it turns out that we're just going to jump in with the basic operations. And I guess rather, we could either call it basic operations, which is what I'm going to go with, or we could call it example, because we're just going to do a bunch of examples. We're going to start with an example today. So for this example, we're just going to jump in and we're building intuition for it is all that we're doing. Cool. Here we go. We're going to need two functions. I want to let f of x equal, and all I need is a polynomial. I need any nice function with regular nice coefficients. So x squared, I'm going to use both those, plus 6. I'm fine with that. Now, if I needed to name another function, I probably wouldn't call it f again, right? Do you guys know the default for the second one? Y is not typically what we'd use if we're using this notation here. G is the next most common. F of x and g of x. The next one would be h of x. Okay. Anyway, let's make this one a little bit uglier. X squared plus 2x minus 1. All right. Everybody cool?
I don't even know why she's laughing.
Yeah, I'm not sure either.
Keen was looking at me.
I saw that too. But are we cool with these or just two functions?
Yes.
Okay, here's my challenge. I'm going to give you a minute. Even if you say, I don't know what to do, I want you to try what you think is right. If it's wrong, we'll cross it out and I'll have you tell me, and theoretically everybody, because being wrong in math is like a really important part of it. But check this out. I want you to try to do the following for me. I want you to do, and you're not going to have any clue off the bat what this means, but I want you to just go with your gut. I want you to find me f plus g of x. And I want you to try it, and if we got to talk about it here in a second, we will. And I want you to do f minus g of x. I'm going to give you a moment. I want you to try something. Even if it's not the way, like I'm not going to tell you the way right now. Show me what you want to happen. If you got to write the rules for what you think is happening here, how would it work? You can chat with each other. You can bounce ideas off of me. You can't sit there and write nothing or just go to the bathroom to avoid doing it. If you're wrong, that's okay. I want you to be wrong. I don't think you will be. Try it. Go with your gut. I'll be around to help answer. Deck, if you're watching this, you should pause it, and when you resume, you will see, we'll start the walkthrough. But we'll go ahead and do that in 3, 2, 1. On what I saw you guys doing, and 3 or 4 people were already doing this without me being more specific. If I just say, forget about this x for now, it becomes, I think, more obvious. What did you guys write? And two of you, Beatrice, I liked your answer. What was the very first two things that you wrote on line 1?
X squared plus 6.
I'm going to pause here. X squared plus 6. And then I assume that you added something to this.
I did plus x squared plus 2x minus 1.
Okay. This is what, even if you had an extra x, this is what most of you that had anything written would try. Because you saw this and you said f plus g, and here's f and g, and you try to add them up. Does that seem like the natural choice? This is exactly it. This is how we do this. Now, we have to simplify. Like, we're going to try to simplify. Are there like terms here? Yeah. Now, I add the parentheses. And I will always add parentheses if I'm doing substitutions, because if we don't, we'll miss stuff. Now, maybe on this one it won't matter, but the next one it will be super important. What's the number outside of these parentheses?
1.
So do I really need them?
No.
No. So if I just drop them, and I'm going to pretend like they're just not there, and I'm just going to switch to a single color at this point. We'll stick with yellow. It's like I can just imagine they're gone. There's nothing there. Are there, how many x squareds when we add them all up? So be careful. Are you multiplying them, or are you adding like terms?
Adding like terms.
So what's 1x squared plus 1x squared? 2x squareds. Kian, I like what you said, but you didn't add them. You did what? Starts with an and ends with multiplied. You multiplied. How many just x's do we have anywhere? So I'm going to lightly cross these out. This is the only x term, right? So we still have plus 2x.
Correct.
And the very last one. 6 plus negative 1 is 5. This is our new function that we got by combining two of them like this. Now, we're going to generalize these rules here in a second. With this in mind, if I wanted to do this one, help me out with it.
X squared plus 6
And I'm not going to change colors this time, if that's okay with you. X squared plus 6.
minus x squared plus 2x.
Okay, here's a big question. Again, notice, I did the parentheses, right? Do these parentheses matter? Let's look. What's the number outside of these parentheses that everything is multiplied by?
Why is it negative?
Oh,
This one is just 1, right? Okay, so these parentheses don't matter. What's the number out front of this one, though?
Negative.
And if there's parentheses around it, it tells me I have to do what? Distribute, multiply, whatever. If you don't include these parentheses, there's a 0% chance you're going to multiply through, right? We have to add these parentheses, especially with the subtraction, because what we wind up with is x squared plus 6. That's this one still. And what's this give me? And this one? And this one.
Would it be plus 1?
It is. Now, as I look at this, these parentheses matter huge. If sometimes they matter and sometimes they don't, you are way better off erring on the side of caution, just assuming they always do, and then removing them if they don't. Okay, help me simplify here. X squared minus x squared.
It cancels.
They gone.
And then a 6 and a 1 is a 7.
So plus 7. Negative 2x plus 7. And it seems like we have it. Okay, for these, we're going to define and make this rule super duper clear here in just a moment. Are these crazy hard? No. Do you agree that, and maybe not, I don't need just a yes or no, is this possibly the easiest thing we've done in here?
I think so.
Okay, so it's not the worst, we can all agree. Okay, so there's one more basic operation that we're going to knock out. Now, we probably won't really hit division today, just so you're aware. We can talk about it briefly, but there's better ways to do the division stuff. What's the only other basic operation if we already have f and g defined? Hey, how do you think f, and notice, and I want you to very carefully do the exact same thing as me. Normally we use dot as multiply, right? I'm not going to here. And there's a reason that I'm not, I promise. If I just write fg, are they still multiplying? Okay, I want f times g of x. What does your gut say we should do? Do you want a minute to try it alone? Do you want to talk it out? Okay, talk it out quietly with your neighbors. I'll give you about a 60-second head start, and then I'm going to ask you guys to help drag me through it. Starting now. No longer does FOIL work. FOIL doesn't work. We don't call it FOIL anymore. You may want to call it FOIL, but FOIL only has first, outside, inside, and last. When we do this, as I was coming around, I didn't look at everybody's, but I saw at least, I think, maybe I did look at everybody's, but we'll see. What's happening between these two? I'm multiplying. So as I look at this then, what is f of x?
X squared plus 6.
So here it is. Am I going to put parentheses around it?
Yes.
Always, if we're adding something in here. X squared plus 6. And what's g of x that we're multiplying it by?
X squared plus 2x minus 1.
Okay. Here is where we're at. Now, you guys need to be able to do these. And I think you can, but let's just work through together. Can you guys FOIL? Is everybody in here comfortable foiling?
Yeah, probably. Yeah.
If you're not, it's okay. That's a bad way for me to ask that question. Do you guys physically draw the lines?
Yes.
I'm going to. I do it every time. So check it out. We can't use FOIL because we have more than outside and last in this one. It's the only reason we can't. There's an extra term. But it's the same thing. It's just distribution. What's the first part of the multiplication that we should do?
X squared times x squared.
Okay, I agree. And realistically, and I'll do all these, what does that one give me?
2x, or no, x cubed.
X to the fourth. Okay, and we'll clean these up. What's the next part of my multiplication?
X squared times 2x.
And what do we get? Is it squared? To the third. Cube. I'm fine with that. I wasn't criticizing. What's the next one? Can I just write minus x squared? Which one of these three, Lucy, are you?
2x cubed.
Okay, so check it out. I don't want you to do this every time. There's some rules at play here. Do you agree that if we do x squared times 2x, do you agree that x squared is just x times x? And 2x is just 2 times x? So if we rearrange, because multiplication can, could I write it like this? 2 times x times x times x.
Yeah.
What is x times x times x written as?
Cubed.
And what's the other number here?
2. So then why is there an x after the 2? Wouldn't that go into the cube?
Hold on. Isn't this the same thing that we just have there? Like this is 2 times x cubed. And this is x times x times. I'm not quite sure where the hiccup is.
Oh, I see. I get it now.
Okay. Are we done? No, we have half the problem left to do. What's the next multiplication we need?
Oh,
What is that one?
6x squared.
And this one?
12x.
Good? And this one? Negative 6. Okay. It takes a little bit of time to do them. My advice is if they ever come out backward and it's the 3-nomial on the left instead, it looks weird and you guys are going to hate it, I think. I'm not going to switch colors. But it's certainly possible that I had given you g times f, right? Which is same stuff multiplying. You do not need to write this. I just want to make sure I can address it. If I had written it like this, it is the same problem, right? But if you draw your lines, are you going to draw them the same? Now, probably not. If you're used to drawing these lines, and I would encourage you to draw them, but I think it's pretty natural that somebody would do it like this. Boom, 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 and boom, boom. Okay. Or, and this is what you're going to hate, I think. That looks kind of gross and ugly. This one, less gross and ugly?
Yes.
Could we multiply like this? And just do the exact same thing just from this side? This is how I would do this problem. I wouldn't do it in 3 groups of 2 like the first time I drew it. I would do it just like here. I just changed the order. I'm still going first to first, first to second, first to third. Second to first, second to second, second to third. I'm doing the exact same thing. Okay. What can we clean up about this one?
Adding like terms.
Okay, so let's do that. And then we'll take our brain break. X to the 4th, that's the only one that I have.
Yeah.
And I'm going to cross it out lightly. Let's see. This is the only thing with x cubed, right? So it just stays plus 2x cubed. I'm going to cross it out lightly because I've done it already. How many x squareds do we wind up with total?
2.
Why 2?
Oh. I was just looking at negative x squared and 6x squared.
So I like that. If you combine those, how many of them do you have?
5x
I like that better. Negative 1x squared and a positive 6x squared make 5 when you combine them. Plus 12x minus 6. And we're done. Now, for these, there is a big, awesome observation to make. And this is kind of far out there math. We're going to do like 2 minutes here, just so we can talk about an idea that I never saw until, I don't know. I've never seen it in an Algebra 2 book, but it's awesome that it works. And we've actually maybe kind of brushed around with it real quick. Did we start with 2 polynomials?
Yeah.
Like there's no weird exponents, there's no dividing by x, like these are allowed. Is my end answer a polynomial?
No.
You say no. So poly just means many.
Oh.
Is it still like, am I dividing by x anywhere? Nope, no division, no fractions anywhere with x's in the bottom. Do I have any weird powers like 1/2 or 2/3 or anything like that? So this is still a polynomial. When I add 2 polynomials, do I get a polynomial? When I subtract 2 polynomials, like I did here, do I get a polynomial?
Yes.
If I multiply 2 polynomials, like I did here, did I get a still polynomial? Now, the big idea here that we're not going to hit hard other than just talking about it is we're going to define this idea. It's called closure. Now, there is a whole set out there, a big collection of with any number of power and leading coefficients, we have the whole set of every possible polynomial that can be written. It's infinitely large, but they're all polynomials. We're just going to make this last little statement. Polynomials, and it's really 2 statements. Polynomials are closed under arithmetic. And I'm just going to say under addition, subtraction, and multiplication. Now, all that this means, and this is a really big statement, but we've seen and you've worked with closure your whole life, you've just never been aware of it rather. All that this means, closed under these operations, is that if I do any of these operations between polynomials, I still get a polynomial. It gives me the same thing. So if I think of the whole infinitely many polynomials that exist, all of them, which infinitely many, if I add 2 of them together, I'm going to get something else that's already there in that big group. If I subtract 2, I'm going to get another polynomial that was already in that big group. They are closed. Now, it turns out maybe closure isn't a weird idea for you, and the weirder idea would be if it weren't. But you've been doing this. If I add 2 real numbers, do I get a real answer? Yeah. If I subtract 2 real numbers, do I still get a real? 0 is a real number. Like no matter what I do to real numbers, add, subtract, or multiply, I still get a real number, right? They are closed. Are the imaginary numbers closed? Yes. If I add 2 imaginaries, do I get imaginary?
Yes.
If I subtract, do I get imaginary? If I multiply, do I get imaginary?
Yes.
Do I? What's I times I? Is it imaginary? I squared isn't imaginary anymore. They're not closed. And that's a weird thing for us to see. Every other thing we've dealt with is. Okay. Now, we are going to take a quick brain break. Because nobody in here right now is a pure math studying mathematician, I want you to know that this exists. We're not going to focus on it. If somebody in here winds up pursuing mathematics, which statistically, very low chances of that, not because of anybody in here in particular, but there's not many people that study pure math. Like, it's pretty rare. If you study pure math, you will talk about this a lot. If you study engineering or science in like the hard sciences, not hard difficulty-wise, but it's just what we call the sciences, physics, biology, chemistry, any of those, you will probably have to take a math class that involves these again. Okay, with that said, we're not going to talk about them again. Okay, so